Lenz law, the statement of Lenz law is nothing but the polarity of induced EMF is such that tends to produce a current which opposes the change in magnetic flux which produced it. So this is the statement of Lenz law. So listen carefully. Once again I'll say the statement. So the polarity of induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produced it. Okay, here I'm going to consider that one loop. This is an empty loop. There is no current flowing in that loop. And again here I am consider that north pole of the magnet. Here north pole of the magnet is moving towards the coil. Moving towards the coil, what will happen? Anti-clockwise current is produced in that coil. So when anti-clockwise current is produced in the coil acts as a north pole. So this coil acts as a north pole. So when the coil acts as a north pole, again this north pole of the magnet is moving away from the coil. It means that repulsion will happen in between the north pole of the coil and the magnet. Okay, so again, if we take that one more condition, here I am taking that another loop. When the north pole of the magnet is moving away from the coil, so what will happen? This north pole. Here, this north pole of the magnet is moving away from the coil. So again, here the current is produced in clockwise direction. So when current is produced in clockwise direction, the coil acts as the south pole. Okay, so the coil acts as a south pole. So we know that when coil acts as a south pole, again north pole of the magnet is attracted towards the south pole. Okay, then what is the meaning of this statement? Here the polarity of induced EMF. So induced poles of the magnet, the polarity of induced EMF. When we introduce the poles of the magnet towards the coil, what will happen? Is such that tends to produce a current. Obviously, it will produce the current, but north pole of the magnet is moving towards the coil. It will produce the anti-clockwise direction. When we north pole of the magnet is taking away from the coil, it will produce a clockwise direction. Okay, so next one, which opposes the change in magnetic flux that produce it. So actually, this poles of the magnet produces that. Due to this magnetic flux, the current is produced in that coil. So this coil current, the anti-clockwise or clockwise current, again opposes that magnetic flux produced it. So what magnetic flux is produced in the current opposes that same magnetic flux. So this is the statement of the polarity of induced EMF. Okay, so now, okay ma'am, suppose if in case now south pole of the magnet is moving towards the coil, what will happen? So again south pole of the magnet is moving towards the coil. Here the clockwise direction of current produced in the coil. So the coil acts as a south pole. Then again same process.